Greetings, everyone. My name is Rumbidzai Chivizhe, and I'm the corresponding author. And the other authors are Dr. Juliana Useya and Mr. Rizen Mlambo. We are all from Zimbabwe. So the topic of the article is of the paper is damage and loss assessment due to Cyclone Idai's flooding events in the Chimanimani district. So as an introduction, in March 2019, Zimbabwe was hit by a tropical cyclone which was named Cyclone Idai. These devastating events came with extensive flash flooding, landslides, and very high-speed winds, which caused huge destruction in the district under study. This paper, however, focuses mainly on the destruction that came as a result of the flood. So the aim of the study is to determine the impacts of a cyclone Idai and conduct damage and loss assessment focusing on the vegetation built up areas and the flood extent. So here's just a glimpse of what the cyclone Idai was. Here we have a washed away bridge along Mvumvu River in Chimanimani. So the objectives of the study, the first one is mapping the flooded areas, and then the second one was to assess the impact of flooding due to Cyclone Idai through moderate spatial resolution imagery, which is the radar. Which is for the radar, we had Sentinel-1, and for the optical, we had Sentinel-2 images. So to determine the amount of damage and loss caused by Cyclone Idai's flooding events was the third objective. Here we have the study area, which is Chimanimani district, and we have Chimanimani's agroecological regions map shown in the slide. Then just a brief description of the Chimanimani district. It is a mountainous district in the Manicaland province of the southeastern side of Zimbabwe. It serves as the district's capital and it borders Mozambique on its eastern side. So Chimanimani experiences rainfall for about 10 months and 2 months of practically no rain. The wettest month is January, which normally has an average of 7.6 inches, and the driest is August with an average rainfall of 0.3 inches. The majority of soils in the district are white sandy soils, which have very limited water retention capacity and low. So for the methodology, I'm going to start by the Sentinel-1 ground range detected image that we used. For Sentinel-1, we use Sentinel-2 core software for pre-processing. So we had the before flood mosaic and after flood mosaics. So the first process was to have a subset of the area that we specifically wanted to do the pre-processing for. Then there was multi-looking, the geometric calibration, and terrain correction using SRTM, arc 1 second DTM, and then finally there was layer stacking. So for layer stacking, we used the before image and the after image to create an RGB composite. So for the before image, we took the red band, and then for the after image there was the blue and green band. The purpose of this is to make the flooded area appear in red because they will have high red channels response and low green and blue channels, with the area with no flood appearing with tones of gray and a bluish color. After that, we had our flood extent map, and then from there was the vectorization of the flood extent so that we could just focus on the flooded area. So for the Sentinel-2, we are still on the flowchart. For pre-process, we downloaded the image which was on level 2A, which means it had already undergone pre-processing the first pre-processing stages, which is atmospheric, geometric, and radiometric correction. And then we use the Sentinel-2 core software, which we use to perform atmospheric adjustments. So from there was the application of indices, which is the NDVI and the NDBI indices. This is for the optical part. After that, so for the NDBI, we use the shortwave infrared band and the near infrared band. And for the NDVI, we use the near infrared and red band. Then the results were then reclassified, and then change detection was done through NDBI change differencing and NDVI differencing. So from there, we then performed feature level fusion. This was done by masking out the flood extent and combining the vectorized flood extent with the NDBI change map, which then resulted with us having only the flooded NDBI change map and the flooded NDVI change map. Then from there, we carried out the damage assessment. So for the results, this is the Chimanimani flood map. We have two insets showing us clearly how the flood appeared. Here it appeared as those red components. And as we continue, we're showing Chimanimani for the first image is a pre-flood period with dark gray color representing the river channel, and the post-flood period with red color representing the flooded channel. So for the histogram that we got for the sigma naught VV, it shows here by comparing these two images from the second one. The second one has a huge bump, which now discriminates the period there was flood from the period where there was no flood as yet, which is the 7 March 2019 image. So this is the vectorized flood extent map with an inset showing us that white line going through is the existing river channel, and the yellow or orange appearing parts are the flooded area around the river channel. So for the vegetation index, the NDVI with the before and after one, A is the pre-flood period and B is the post-flood period. We can see the difference here was where there is flood. It's actually clear on the second image where the channel was now clear because there was now flood. So for the change NDVI change after differencing, the first map shows the differencing before there was feature level fusion. Then the second one shows where we had done feature level fusion so that we could only remain with the flooded area, NDVI flooded area map. For change detection statistics, the positive change, we had a positive change, no change, and negative change. The negative change was 93.91%. That happened to vegetation along the flooded areas. No change was 0.11%, and the positive change was 5.98%. Then for the built-up index, we can also show the difference with the pre-cyclone and the post-cyclone Idai. For both the pre and post, green represents the non-built area and red represents the built-up area within the flooded areas. So for the NDVI change map. This was the first one is the NDBI change map. Then the second one is the NDBI change map for the flooded area. This was after feature level fusion. This is the results that we got. For positive change, it was 24.56%, no change 51.19%, and negative change was 28.25%. So we also carried out NGWI, which is the water index, just to validate if the flood extent that we got from Sentinel-1 was the same as the one that we got through NDWI method. So it's clearly shown that the same extent was obtained through this method. So for damage and loss assessment, we also carried out a logical combination of the spectral indices, the vegetation, the built-up area, and water indices. So for built-up, which was equal to NDBI with the built-up index minus the NDVI. Thus, the combination for NDVI was greater than 0, NDWI greater than 0.2, and we had the built-up index. So we then reclassify the image to show the mapped combination classes, which are vegetation, built-up, and flood. So fusion of the vectorized extent with the reclassified image was done again in order to extract only the flooded areas. This was the combination, how it looks like, with the blue showing the flood, green the vegetation, and red the build-up. This also shows the vectorized change map, which shows the flooded area specifically, where we have the built-up, the vegetation, and the flood. So just for accuracy assessment, to check if our work was accurate, we added the area in hectarage for the vegetation and the built-up if it amounted to the same area where there was water or where there was flood, and it came up to be equal. So I believe it was accurate. The method was accurate. So for the impact of flooding then, for vegetation change analysis, NDVI differencing for the flooded area was used to achieve the results showing the impacts of flood to vegetation. So the negative change, which was 93.91%, shows us that almost all the vegetation within the flooded areas was greatly affected. This can be explained by the image I showed you earlier of the bridge that was swept away and the plants which were planted on the river banks, most preferably those ones were the ones that were swept away by the flood. So, and in the case of Chimanimani, there are maize fields, banana fields, sugarcane, yam, and grass, and a positive change of 5.98%, I believe, shows those areas, for example, with plants, vegetation which adapts to flood, and some trees like mopani and acacia and rice fields. And the built-up change shows us that around 50% there was no change, which means those buildings were not affected. But for 28.25%, there's a negative change, which includes the swept away bridges, swept away houses, among other infrastructures like roads. Then the 20.56% for the positive change, I believe, shows some building materials that were detected by the sensor and some people who could have started reconstructing their damaged buildings. So based on the statistical results, the damage in vegetation was for 3,475 hectares of land, which is roughly 93.52%, and the built-up damage extent was 28.25%. So as an analysis of results, most of these built-ups were along waterways because people choose those areas with water because that's where they have most arable land and better water retention properties. So So poor quality building materials were used in rural, mostly used in rural Zimbabwe, becoming the reason why there was so much destruction along of the houses that were built along the water channels. So as a discussion, the objective was achieved using the Sentinel-1 and the Sentinel-2 images. And in conclusion, I would conclude that the synergetic use of the radar and optical and remote sensing images gives us better results, as these two components complement each other in research basing on their different capabilities. As a further recommendation, I would recommend a further study using the same approach to assess the damage and loss, with specifically the best image resolution imagery and assessment in other areas. I thank you.